So in our first session for today, we're going to begin our discussion with reflexive access lists. Now, up to this point, we already talked about the state list filters in iOS with regular standard access list, extended access list, time-based ACLs, lock and key or dynamic ACLs, and now we're going to get into the point where we're moving towards the stateful firewall, starting with reflexive ACLs, moving into content-based access control, and then ultimately to the zone-based policy firewall, which is the new unified syntax for the firewall feature set. Now, for the reflexive ACLs, the main goal of this, and this is, we'll see, it's kind of a legacy feature because it is replaced now with the other features of CBAC or zone firewall. But the idea of this is that we want to add some basic state tracking to access lists, where as traffic flows are going through the router, some ACL is going to trigger a mirror entry in the state table, which means that when return flows come back in, the router is going to check that state table first before it denies traffic based on an ingress ACL. So if we look at this from a visual point of view, and we're going to be using router 3 here in the middle as our stateful firewall today, the basic idea is that if we were to say that the link to the test PC is the inside and the link to router 2 is the outside, so the outside being the unprotected network and the inside being the protected, trusted network, the main goal of the stateful firewall is generally that we want traffic to come in from the inside and go out. Then when traffic is returning in on the outside interface, we only want to allow these flows inbound if they are return flows from traffic that was initiated on the inside. So for example, let's say that behind router 2 here we have a web server and the test PC wants to do regular web browsing to this. Now, based on just how the normal TCP transmission works and the initial three-way handshake, when the test PC opens its web browser, the first thing that it's going to do is at TCP port 80 to the destination, it's going to send a SYN, saying that I want to start the three-way handshake. Now, when the server receives this and it accepts it, so Apache is running, it's running the web service, the web server should respond with the second portion of the handshake, which is the SYN and the acknowledgement, so the ACK-SYN or the SYN-ACK. Then finally, the third portion is going to be the web browser on the PC replying with the acknowledgement. Now the three-way handshake is open and the connection is established. Now the main ultimate goal of the stateful firewall, and we'll see that this is the case whether we're dealing with iOS or whether we're dealing with ASA, is that it wants to only allow traffic to leave the network that is inspected and only to allow return flows in that were originated from the inside. Now, of course, we'll see other more advanced examples of this where maybe we're allowing outside flows in, or we have 3 or more zones like a DMZ link, for example. But in general, the point is that we want to only allow the traffic into the network if it was initiated from someone on our trusted network on the inside. So this is what we're talking about when we're referring to stateful filtering as opposed to stateless. Where in the case of a regular access list, even if we were to use something like the established keyword in an extended ACL, the router has no way to actually look at these flows as they're going out and then selectively decide whether the traffic is going to be permitted in or whether it is going to be denied. Now, we'll see that one of the disadvantages of using the reflexive access list, and one of the reasons why it's now considered basically a legacy feature, is that traffic is basically allowed to return back in until a specific timer expires. So there's going to be an inactivity timer. It's 5 minutes by default. We can change this if we want to. There's a reflexive list timeout command. But basically what this means is that the router is essentially opening an outside-in hole in the ACL for a certain period of time, and it doesn't have anything to do with the specific application. So the router doesn't know what is the payload of web browsing that we're looking for, the HTTP GET, the HTTP POST, etc. It just sees that this is, at layer 4, it's TCP traffic going to port 80 from this source to this destination. So for a return flow, I would allow anything that is the opposite ports, so source 80 going to the random destination port, and then with the source and addresses flipped. So there is no specific application inspection. This also means that reflexive ACLs are only going to work with standard TCP and UDP applications. So I'll talk about in a minute more specifically what that means, but a good example of this would be IP telephony. So if we have an IP phone that's on the inside of a reflexive ACL configuration, when the traffic leaves the network, the issue is going to be that the return flow is not a mirror image of what the outbound flow is. So the reflexive ACL is not going to be able to deal with this, and it's going to ultimately drop the traffic. This is the reason that we have in the content-based access control, the zone-based firewall, and in the ASA's modular policy framework that we need those application-level inspections, that we know what's the protocol signature for web browsing versus a DNS request versus a send mail request, because different TCP UDP applications are going to have different outbound versus inbound signatures, and if the firewall doesn't know that, it's not going to be able to automatically allow the traffic flows to come back in. Now, from a configuration perspective with the reflexive ACL, the first step is that we need to watch the traffic as it is leaving the network. So in our specific case here, if we go back to our diagram here, if we're trying to get router 3 to allow flows as they are leaving out toward router 2, we're going to configure an ACL on this interface here, fast Ethernet 00.23 outbound, that is watching the traffic. And specifically, it's going to have the keyword to reflect. So this last option here, the word stateful, this is any arbitrary name that we're coming up with here. This is basically the name of the state table. Then when traffic is coming back in the reverse direction, so let's say that we have that web request, the router basically is going to say that the source was the test PC and the destination was, let's say, router 2. It's going to track what is the source port, and in this case the source port is going to be random for a web flow. The destination port would be 80 for regular web browsing, and it's now tracking this in our state table. Now when traffic wants to return back in and tries to come in on the outside interface, we're going to have a separate access list configured that says we first want to check the traffic that is in the state table, or we want to evaluate whatever that particular name is, which is going to dynamically allow those flows to return. Now the key with this is we need to make sure that the evaluate statement comes above either our explicit or implicit deny, because this is going to be processed top-down just like any other normal access list. Now we'll see when we look at the difference between content-based access control, zone-based firewall, and the reflexive list, there's a different order of operations as to how the return flows are checked in the state table versus the access list. But here in this case with the reflexive ACL, the order of operations is important. We need to make sure that we are evaluating the traffic towards the top of the list, and then our static denies would be underneath. Otherwise the flows would not be allowed back in. Now another potential issue with the reflexive access list, and this doesn't necessarily relate directly to reflexive ACLs, this is just an issue in general with iOS and how its order of operations with ACLs work, is that the locally originated traffic from the router's control plane is not classified by an outbound ACL. Now the easiest way to show this type of example is if we go to let's take a look at our diagram. And let's go to the CLI here. Let's say that we go to router 1. And on router 1, we have, if we look at our routing table, we should be learning routes to router 3 and router 2 out the interface gig 0/0. So we see the routers have loopback addresses. This is router 1, router 2, router 3. And from router 1, we should be able to ping from us to router 2. Okay, so basic reachability is already established in the topology. Now, if I were to create an access list that simply says to deny all IP traffic and go to that interface and apply this as an IP access group outbound, then we go to send our traffic flows, you would normally assume that this traffic is going to be denied because it says any outbound flows on gig 00 are going to be denied, any IP packets. But the issue is, from an order of operations perspective, this locally originated traffic from the control plane So things like ping, traceroute, telnet, OSPF, hello packets, this is not classified by the outbound ACL. And we'll see that this is going to be a problem related to reflexive list, to content-based access control, to the zone-based policy firewall, because it's not directly related to security per se, it's just an order of operations of how the router generates traffic out the interface. Now, from an inspection point of view, when we're talking about the stateful firewall, the issue is going to be that the locally originated traffic then is not going to be inspected by our outbound policy. So this means that it could break our control plane protocols like IGP routing or BGP routing. It could also affect any of our local testing traffic like a ping or a telnet or a traceroute. So we do need to go one step further, regardless of whether we're doing reflexive, CBAC, or zone-based firewall, in order to make sure that these return flows locally from the router are allowed back in. So the easiest solution for this would just be to manually permit these flows in the return-bound access list. Now, another kind of stupid router trick would be to do local policy routing, which basically forces the router to treat its own traffic as transit and changes the order of operations of the ACL classifier versus the local traffic. But in general, the simple solution for this is that if the router is locally generating traffic out the interface that has an outbound ACL, we need to make sure to manually account for the return flows on the inbound ACL of that same interface. Okay, otherwise, we'll see that it breaks things in the control plane like our basic routing protocols. Now, from a documentation point of view, if we go to the main documentation page and go to Products, iOS, Regular iOS, 15.2t, Configuration Guides, this feature would be documented under Security, of course, and then securing the data plane. So all of our firewall filtering, whether it's stateless access lists with just regular standard or extended ACLs, or the stateful filters, which in this case is going to be content-based access control, the zone-based policy firewall, and then under access control lists, we should have an option here for IP session filtering with reflexive access lists. So if you want to read more about the features, see what are the particular options that you can change. This is where it's documented, but we're not really going to go through all of their examples. It's a pretty straightforward configuration in the scheme of things versus the other examples. Okay, so let's take a look back at our topology. And again, what we're going to be doing on router 3 is configuring an outbound ACL that is going to reflect the traffic to the state table. So the state table is going to track any traffic from the inside going out, and then as traffic is coming back in, we are going to evaluate whatever the entries are in that state table. So we're essentially, again, just changing the order of operations of what happens when the flow comes back in on the outside interface. Do we check the state table first, or do we check the inbound access list? So first, before we make any changes, let's make sure that we have basic reachability between all of the devices. So let's take a look at the interface from the test PC's point of view. And it right now should be able to ping to router 2, which we see it can. We should also be able to trace route there, for example. 150.122 is router 2's loopback address. We can see that its first hop, its default gateway is router 3, and then router 2 is directly attached there. If we were to go to router 2, and let's turn the web service on, so globally, let's say IP HTTP server. Then on the test PC under its web browser, let's browse to router 2's loopback. Okay, and we can see we get the login message in order to manage router 2 from the web interface. So we can see at this point just the basic flows without any filtering are working. Now, within the scope of the CCIE lab exam, you always want to make sure to do these basic tests before you move on to any specific security topics. Because I don't want to be troubleshooting my zone-based firewall or my DMVPN or my EasyVPN server and then figure out there was something wrong in the basic IP addressing or the routers didn't have an OSPF adjacency between them. So always test from the ground up. Make sure that your basic layer 2 and layer 3 is working before you move on to any of the security specific topics. Okay, so let's jump back to router 3 here and look at our topology as well. So router 3 is going to need to do two things. It's going to need to have an access list that is on the outside interface outbound, and it's going to have a separate list that is on the outside interface inbound. So we'll say that these are outbound out, or outside out, and then outside in. Okay, this is an extended list. And we're going to permit whatever flows that we can. So let's say permit all TCP traffic. And when we permit it, we are going to reflect it. So create a reflexive access list entry. Reflect it to whatever name that we define here. Okay, so we'll say that the state table. And the same is going to be true for any of our other flows. Let's say UDP and ICMP. So probably 95+% of the flows are going to be one of these three protocols, at least from the user's traffic point of view, not from the network control plane point of view. Okay, now on the return path, if we say IP access list extended outside in is going to evaluate the state table. And what we're also going to do here is something that I mentioned in the previous section related to access lists, that we're going to put an explicit deny at the end in order to do logging to figure out what are the other possible flows that we need to allow back inbound. Now again, if you're doing this in production, you don't want to end your ACLs with a deny log, because all of the drop traffic is going to be process switched, and then it could spike the CPU of the router, and then you could have some reachability issues, like you start to lose your BGP peerings or lose your OSPF adjacencies. But for our sake here, since we don't really have traffic in the data plane, we're going to do a deny IP any at the end and say log. So let's show run section access list. So we have two lists. One is going to track the traffic as it leaves the outside interface. That's the one that's reflecting it to the state table. As the traffic comes back in on the return flow outside inbound, we're saying check the state table to see what traffic should be allowed. Then if it's not anything that was already inspected, we're going to deny that traffic. So our interface here is F00.23. We're going to say IP access group outside out is applied outbound, and outside in is applied inbound. Okay, and let's make sure we're logging to the console. Now we can see already, once we applied the list, we're starting to get some log messages here. One of the first ones says that we denied on the outside interface inbound OSPF traffic that was coming from router 2 going to the OSPF multicast 224.0.0.5. Now, even though we are locally generating OSPF packets, and if we take a look back at our diagram, router 3 right now has the ACL applied out, and then the reverse direction out, in. This one is the one that is denying OSPF, because it's saying first to evaluate the state table, but the issue is that the locally generated OSPF traffic, which is our protocol number 89, that's going out on that interface, this does not hit our outside out ACL, so the router doesn't know to dynamically permit the traffic back inbound. So again, this is one of the issues we'll see that is related to reflexive ACLs, CBAC, and zone firewall, that anytime we're filtering on the router's interface in the data plane, we need to make sure to also account for any of our control plane packets. So basically what this just means is that we need to go to that ACL that is outside in, and then before we get to our deny that is essentially our implicit deny, we need to put another statement that is above that and say permit our OSPF traffic or permit our BGP traffic. So whatever control plane protocols the router is running, we need to make sure to take that into account. Now we'll see as we start to get into more detailed scenarios, the amount of control plane protocols is going to start to build, whether we're using ISACAMP for our phase 1 IPsec negotiation. For phase 2 tunnels, are we using ESP or AH? If we're using Get VPN, we would have to allow the GDOI negotiation. Maybe we have network time protocol. Maybe we have web browsing for doing certificate authority registration. So we need to make sure to take all of these protocols into account. And the easiest way to do this, as opposed to just memorizing all of them, is just to use this ACL log. Okay, we can see now there's the OSPF adjacency is dead, simply because those flows were denied as they came back inbound. So let's show run section access list again. And basically what we need to do now, or actually let's just say show access list because we need the line numbers. I need to insert an entry between 10 and 20, and I could have put it above 10, which is fine. But as long as it's above the explicit deny, for IP access list extended outside in, let's say sequence 15 is going to permit OSPF any. If we were running EHRP, likewise permit EHRP any. If we were running RIP, this would be UDP any equal to 520, which is RIP. If we were running BGP, this would be to permit TCP any equal to 179 for BGP, but also sourced from 179 because we would need to account for the bidirectional flows. So if we show access list here, we should see hits on the OSPF entry because that's the particular routing protocol that we're using. Okay, we'll see later as we introduce other protocols like BGP, how does this affect the firewall filtering. Okay, if we now look at the show IP OSPF neighbors, we want to make sure that router 2 and router 3 have an adjacency, which they do now. Okay, so let's see from the test PC, what has this now changed in the traffic flows from them. So are we still able to ping router 2? Yes, we are, because we're inspecting this traffic as it leaves router 3. And if we look at router 3 now and show access list, this traffic that came from the PC, which is this address here, 10.1.0.100, we now put it in the state table, but notice that it is in the opposite direction. And that's basically the reason that this is called a reflexive ACL, that it's taking the traffic as it goes out, and it's making a mirror image of it, it's reflecting it, and then saying the opposite traffic flow is the one that should be allowed back inbound. So there's really no application level intelligence here, it's just saying that I saw ICMP traffic go out, it came from 10.1.0.100, it was going to 150.1.2.2, so flip those in the ACL entry, make this the source instead of the destination, make this the destination instead of the source, and then allow that open for a certain period of time. Now we'll see this also means that if we go from the outside in and we go to router 2, let's ping 10.1.0.100, which is should be the test PC here, 10.1.0.100. Okay, we notice that we're getting ICMP unreachable here, capital U. If we look at the debug IP ICMP to see what is this specific message coming in, administratively prohibited, this means it was denied by an access list on router 3. So router 3 is the one generating the unreachable. But if we were to generate this ping and source it from our loopback, it says administratively prohibited unreachable received from them And this is actually because it is matching the type code here. So it doesn't actually list it in this entry, but if we were to, and we would basically have to have some sort of packet generator in order to send these packets, because the router, you can't pick arbitrary fields in the header. But if we were to go to router 2 and generate packets that were echo reply, those would be able to go through the filter. Now we'll see that when we look at the CBAC, zone firewall, and the ASA, they have more intelligence in the application level inspection that they know when one echo packet goes out, one reply should come back in. And when the reply is received back in, it's going to close that individual hole in the firewall or in the session table. But in the case of the reflexive access list, there's no intelligence here. It's just saying that this is the reverse flow that should be allowed back in. Now, if we were to do web browsing to them, let's go back to our browser and let's refresh this page. And we look at router 3. Router 3 should now see an entry for web browsing that is the opposite flow. So the traffic came from the PC. The source port was random. It was 1083 in this case. Destination was port 80 going to router 2, so we're going to allow the return flow back in. Now again, one of the issues besides the locally originated traffic here that we have with the reflexive access list is that it is not application aware. So it only works with standard TCP and UDP applications. Like in the case of web browsing, that's going to be traffic going to port 80, and the return flow is going to be sourced from 80. So this is what we considered a standard TCP application. Same would be true like if we were to do a telnet or an SSH. So the firewall would be able to catch that because the outbound flow is the reverse of the inbound flow. So if we telnet to 150.122, we can see that we're able to get to router 2. Now, a good example of a non-standard flow would be our trace route. So previously, the trace route that came from the PC was allowed. We can see that in this case, the trace goes from us to router 3 to router 2, and it is coming in. It's coming in this particular direction. It's going outbound, the flow is returning, and then router 3 is deciding whether to permit or deny it based on the state table. Now, if we look at router 3's entries and look at the show access list, we'll see that we have, and actually let's see if we can clear IP access list, the clear IP reflexive list. Let's actually do this. I'm not 100% sure how to delete the entries. We can just remove the ACL. Let's say outside out and inside in, and then replace them. Now with the other stateful firewalls like CBAC, Zone Firewall, or the ASA, you can clear the individual connections because they're treated separately as like separate entries in the state table. But in the case of the reflexive list, basically this is just in there until the timer expires. So again, we could say IP reflexive list, and then what's the timeout? Like the timeout's 5 seconds. But it's basically not looking at the application signature. Like it's not looking for a TCP reset to come in or a TCP fin to come in to say that you should close that particular entry in the firewall. Okay, so let's look at the show access list. And we could see that there are 14 matches of traffic going from 2 back to 10. And right now on router 2, we're looking at the debug IP ICMP. So while we do that, let's generate a trace route from the Windows machine. And if we look at router 2, these are ICMP echo replies that are coming back in. So let's do the same thing, but from router 1. Okay, router 1, let's ping router 2. We can see that's allowed. If we were to trace to router 2, it says the first hop is router 3, but then the traffic is getting denied after that. So let's take a look at router 3 and see what do the logs show that the traffic was denied. It says we're denying traffic from 2 back to 1, which is ICMP. It says it's type 3 code 3. So again, you don't need to memorize what these are. We talked about this in the earlier session. If we go back to the documentation, and let's go to the ASA documentation. So under Products Security, Firewalls, Firewall Appliance, ASA, then whatever our version is, let's say 8486. Then down under Reference and Addresses, Protocols, and Ports, I want the ICMP types. It says that type 3 is unreachable, and it doesn't show the subcode here, where type 3 code 3 is actually port unreachable, because the router with the trace route is trying to use UDP traffic to a random high port in order to get the destination and in order to reply back with this ICMP unreachable message. Now, the point of this exercise, though, is to show that the trace route, the actual trace RT in Windows, uses a different application signature than the trace route on the router. So the router in iOS, its version of it is the Linux or the Unix implementation, which uses outbound UDP packets in order to solicit inbound ICMP. So it's random traffic going to UDP, or random high ports. We're trying to receive back in either an ICMP TTL expired or time exceeded, and then the port unreachable. Now, in the case of the Windows machine, its trace was allowed back in because it was outbound ICMP, and then the return flow was also ICMP. So they're basically mirror images of them. But in the case of the router's implementation, this is what we would consider to be a non-standard application, that the outbound flow is not the same signature as the inbound flow, and the firewall here on the router then is not going to be able to deal with that because we don't have a specific application level inspection that is talking about this particular protocol. Now, we'll see that this is going to be the case in reflexive ACLs, CBAC, zone firewall, and the ASA, that it's not going to be able to deal with the router's trace route because it's UDP out and then it's ICMP back inbound. So for any of these that are non-standard applications, the solution for this is basically we need to make manual exceptions for them. And we can see where it's getting denied. It's on the list that is outside inbound. So if we show access list, and let's say that, and we can see that it's trying to reflect these individual entries. These are the UDP replies. It says they're supposed to be going back to router 1 and that they're at these random high ports. But that's not what the inbound flow is. The inbound flow is either ICMP time exceeded or port unreachable. So we would then need to go to this list here, outside in, and make some exceptions for this. So let's say show run section access list. And we'll say IP access list extended outside inbound. And let's just say sequence number 1 is to permit ICMP any port unreachable, and also permit ICMP any time exceeded or TTL expired. Okay, so time exceeded, TTL expired, these are the same type codes, TTL exceeded, but they just have multiple shortcuts for them. So now if we show access list, let's say show access list outside in, and we do the trace route from router 1, we can see now it completes and it's allowed back in the firewall. So from router 3's perspective, these were port unreachable matches because in this case router 2 is the final destination of the trace route. if we had other devices behind router 3, let's say that we had a router 4, then 2 would be responding with the TTL expired, which is the time exceeded, and then the final destination would be responding with the port unreachable. So again, this is one of the main reasons why the reflexive access list is considered kind of a legacy feature, that it doesn't have any application intelligence to say when the flow goes out and returns, should I close the hole in the firewall or just leave it open for a certain period of time? And additionally, it has no application level inspections. So we can say permit IP reflected to a state table, but the router is not going to be able to deal with things like an FTP transfer, an IP phone call, the UDP-based trace route as we saw here, for anything that the outbound flow is a different application signature that the inbound flow, since it doesn't have that application awareness, it doesn't know to allow the traffic back in on the ACL entry.